Syntax builds the form we see. Semantics gives it meanings key. Connectives link what minds devise. Quantifiers range through truth and lies. Modus ponens strikes with might. Modus ponens flips the fight. Logic cuts clean, no shallow line. Through the long night, reason shines.
Previously, we discussed truth tables and rules of inference. To prove a proposition of the form if P, then Q, one may use either method. The truth table approach involves examining all rows where P is true and verifying that Q is also true in those cases. This brute force technique ensures correctness, but can become computationally expensive as the number of variables increases, and it often obscures the underlying structure of the reasoning. Alternatively, one can apply rules of inference by assuming P as the premise and deriving Q through the application of a sequence of valid rules of inferences, preserving truth at each stage. This method is conceptually straightforward and clearly reveals the logical structure of the argument, but it often requires insight or strategic observation. In this short video, we illustrate both methods through a toy example to help the audience appreciate the strengths and limitations of each approach. Let P, Q, and R be logical propositions. We aim to show that if the statement P implies if Q then R is true, then the statement if both P and Q then R is also true. Our first method of proof is to use a truth table. To do this, we construct a table that includes all the relevant logical expressions. Since there are three basic propositions, P, Q, and R, the table will have 2 to the power of 3, which is 8 rows, to cover all possible truth value combinations. We then look at the rows where the premise P implies if Q then R is true. In this case, that includes all rows except the second one. For each of those rows, we examine the truth value of the conclusion if P and Q then R, and we find that it is true in every case. Therefore, the implication we set out to prove is logically valid. You can see that in this approach, the task is simply to fill in all the truth values in the truth table, which is a routine and mechanical procedure. However, the compound statement here involves only 3 atomic components. As more atomic components are introduced, the truth table grows exponentially and quickly becomes too large to manage in practice. Next, we proceed by applying the rules of inference. We aim to show the desired implication using direct reasoning. Assume that P and Q is true. Then, by simplification, P is true. Since the premise P implies if Q, then R is also true, and we have P, we may apply modus ponens to conclude that if Q, then R is true. Now, from our assumption that P and Q is true, we also know that Q is true. Applying modus ponens again to if Q, then R and Q, we deduce that R is true. Therefore, starting from the assumption that P and Q is true, we have derived R, and by the rule of implication, we conclude that if P and Q, then R is true. Alternatively, we can confirm this result using rules of replacement. We begin with the premise if P, then if Q, then R. According to the law of material implication, this is logically equivalent to not P or if Q, then R. Rewriting if Q, then R using the same law yields not Q or R. Substituting this back, the entire expression becomes not P or not Q or R. By the associative law of disjunction, we may regroup this as not P or not Q or R. This is equivalent to not both P and Q, or R, which by the law of material implication in reverse is the same as if P and Q, then R. Thus, we have shown an even stronger result than originally required. Not only does the implication hold, but the original statement and the conclusion are in fact logically equivalent. We have seen how truth tables and rules of inference can assist in the deduction process, allowing us to derive valid conclusions from given propositions. As powerful as propositional logic is, it has its limitations. In particular, since the smallest unit it operates on is the entire proposition, it prevents us from accessing the internal structure of statements. To overcome this, we require the use of predicates and quantifiers. We will explore these topics in the sessions to come.
Shinla Tensei